All right, in this section, 10.7, we're going to talk about how we might see radicals in other applications. For example, when we're finding distance between 2 points, or maybe Pythagorean theorem, or maybe other types of right triangle ideas. Let's first talk about Pythagorean theorem, probably an idea you've heard about before. This happens, or can be used, anytime we have a right triangle. So in any right triangle, if you have sides and angles A, B, C, side A is opposite of angle A, side B is opposite of angle B, and side C is opposite of angle C. If C is our hypotenuse, the angle side across from the right angle, then we can say that always a squared plus b squared equals c squared. I'm sure you've heard of it before. I found a cool little YouTube video that talks about how this kind of came about and why this works, and so you might want to take a few minutes to check that out so you really understand where they came up and how it works that a squared plus b squared always equals c squared. Okay, the next thing we're going to talk about before we apply that Pythagorean theorem is what we call the principle of square roots. Now, we talked about the principle of power before, where we can raise both sides to a certain power and the equation would still be equal. Well, same idea with principles of square roots. I should be able to square root both sides and the sides should both be equal. But we have to think about one thing when we're square rooting. If I give you the problem x squared equals 9, what can x be so that when you square it, you get 9? Well, you might think of doing the inverse operation of squaring, which is square rooting. The square root cancel, and the square root of 9 you might say is 3. But you have to be careful. X could actually equal positive 3 or negative 3. Think about that. If I were to plug in positive 3 and square it, 3 times 3 is 9. But if I were to plug in negative 3 squared, negative 3 times negative 3 is also 9. So anytime we square root in order to solve an equation, we actually have two solutions. X could equal plus or minus whatever the square root of that number is. In this case, plus or minus 3. Okay, so let's use both of those ideas and let's look at some application problems. In example number 1, it says a baseball diamond is a square with sides of length 90 feet. Suppose a catcher fields a ball while standing on the third base line 10 feet from home plate, as shown in the picture. How far is the catcher's throw to first base? Give an exact answer, so in radical form, and an approximation to 3 decimal places. So they've even kind of given us a picture here. We know that the baseball field is a square, each side being 90. Because it is a square, we know that we have a right angle right here. It says here that we have a catcher that's 10 feet from home plate, so I know that this distance is 10. I know that this distance is 90 feet, and we want to figure out how far his throw is if he has to throw it to first base. So we want to find this distance, D. You notice that we have a right triangle. Because we have that right triangle, and we know 2 of the sides, we should always be able to find that third side by using Pythagorean theorem. So in this case, a squared plus b squared equals d squared. That's what they called it in the picture. So our a is 10, so 10 squared. Our b is 90, so 90 squared equals x squared, or you can say d squared like the picture did. We should be able to use this now to solve for x and figure out how long it's going to take or what the distance is from that catcher to first base. Let's go ahead and simplify that left side. 10 squared is 100, 90 squared is 8,100. Combined like terms, I ended up getting 8,200 equals x squared. Now if I want to get x by itself, we've got to get rid of that square, right? Well, remember, the function that cancels out a square is square rooting, the inverse function. So I can use that square root property and square root both sides of my equation. When I square the square root or square root the square and the square root cancel, and I'm left with x equals. Now we've got to figure out what the square root of 8,200 is. Technically, x equals plus or minus the square root of 8,200, right? Positive and negative would both work in the equation. The problem is, when we're talking about application problems, a lot of times it doesn't make sense for us to say a negative distance or a negative amount of certain things. So we're only going to use the positive version in this answer because we're talking about this application problem. Now the question asks us to give an exact answer, so that's leaving it in radical form. But let's go ahead and reduce it, and then we can plug it in our calculator to give an approximation to 3 decimal places. I'm going to go ahead and break down 8,200. I did 82 and 100. I broke down the 82 into 2 and 41, and I broke down the 100 into 10 and 10. 2 and 41 are both prime numbers, so I can't break them down any farther. But I noticed that I had a pair of 10s that can come outside. That meant that I had a 2 and a 41 left inside. When we multiply them together, we get 82. So my exact answer, how far that catcher would have to throw it to first base, would be 10 times the square root of 82 feet. Now, that doesn't really make much sense to us, right? It makes a little more sense to multiply that out and figure out what the actual square root of 8,200 is, and then kind of approximate it, if we need to a certain number of decimal places. So I used my calculator, put that in my calculator, the square root of 8,200, or 10 times the square root of 82. You should still get the same answer either way. You should end up getting 90.554 feet. That makes a little more sense. We can kind of envision what that looks like. All right, let's do another one. Example number 2 says the base of a 40-foot long guy wire is 15 feet from the telephone pole that it anchors. So we have a telephone pole. We're going to assume that the telephone pole was installed straight. And then we have the ground, which we're going to assume is horizontal. So we have a nice right angle. It says it's 15 feet from that telephone pole. So I know that this distance is 15. And it says that the wire is 40 feet long. So I have a couple of units here on my right triangle. I have actually two sides of the right triangle. It asks us to find how high the pole reaches, right? How high up the pole does the guy wire reach? Give an exact answer, an approximation of 3 decimal places. So because we have this right triangle and we know 2 of the sides, we should be able to find that third side, the height of the pole, right? By using Pythagorean Theorem. A squared plus b squared equals c squared. Now in this problem, my a is the 15, so I'm going to say 15 squared, plus b, which is my h squared, equals c, because I'm looking for the side across from my right angle to be my c, my hypotenuse. This time, I know what the hypotenuse is. It's 40. So I'm going to do 15 squared plus h squared equals 40 squared. So a little bit different setup makes a big difference in your final answer, so be careful. C is always the one across from your right angle. All right, let's go ahead and simplify. I can figure out what 15 squared is, that's 225. I figured out what 40 squared was, that's 1600. And I still have to figure out what h equals. So let's go ahead and solve this equation by getting rid of the 225 first. It's farther away from the h. I'm going to subtract both sides by 225. I ended up getting h squared equals 1,375. We can get rid of that square again by square rooting both sides. The square and the square root should cancel, and I'm left with h equals, technically, plus or minus the square root of 1,375. But because we're doing an application problem and we're talking about the height of this pole, it wouldn't really make sense for us to say a negative height, right? So we're only going to use the positive version of our answer and say positive 1,375. Let's go ahead and reduce it if we can. I'm going to factor tree it. I broke down 1,375 into 5 and 275. 275 broke down into 5 and 55, and 55 breaks down into 5 and 11. I found a pair of 5s that can come out, but I have a lonely 5 and a lonely 11. That's a 55 that's left inside. So I can say that the exact height of where this guy wire hits that pole is 5 times the square root of 55 feet. Or I can use my calculator and approximate that it's about 37.081 feet high.